González, Associate Professor at EOI, which is a school where we teach machine learning, and I'm also CTO, like a technical responsible in Clever Data. And we've been making machine learning models for the last 5-6 years in the industry. And what I wanted to show you now in my half an hour speech is an end-to-end machine learning project. This is one of the first ones we deployed in production. And it's a bit weird, maybe the title is Tourist Nationality Prediction. And we will see what this means in a moment. And because we will see, as I said, an end-to-end description of a machine learning project, which begins with the business needs and ends with the evaluation of the model, how it's performing. But first of all, I would like to show you how we teach machine learning in the EOI. We have programs, I think it's 6 weeks programs where we teach to business people, and we divide that into modules. My module is the BigML one, and this is the syllabus of the 1 week. It's a 6-day week. We start the module with an initial webinar at late afternoon, I think in English, yeah, at 20 hours at 8 in the afternoon, where the teacher speaks about the theory of the machine learning of the module. I personally show how BigML works, and I also plan the exercises that the students have to solve during the next days of the week. In those next days, we start on Tuesday the webinar, and on Wednesday, Thursday, Friday, and Saturday, they have to make the exercises, and we have a discussion forum where they can ask questions about the exercises, or I also like to put some more stuff for them about theory, or even movies or articles, etc. On Sunday, they have to send me the results of the exercise, and in Sunday afternoon, we have a final webinar where we make a recap of all the exercises, and they can ask questions, and we usually get more in deep in some of the points of the module. In this case, the BigML, the exercises, or theory, or whatever. Okay, so after that, let's see how this use case, and this is the general agenda. We will first speak about the business needs, and maybe you find something strange here, which is the cooking predictions. I like to speak about the machine learning projects like cooking a recipe, because it has a lot of similarities we will see in a moment. We will see where we get the ingredients from, how we clean the data, we transform the data, and as we do in cooking, we cook the predictions in the oven, which is this is something we will see later, and we taste the dish, and it's like evaluating the quality of the prediction. So the first of all, what's the business need of this use case? In the hotel sectors, this is something that some people find strange. In the hotels, they don't know they know very few data of the tourists that come into the hotel before they get to the hotel, before arriving to the hotel. They just know the entrance date, the ending date, how many people are going there in the reservation, and for example, what kind of room they want, but they don't know many things. And hotels want to know, this is something that they told us, they want to know the nationality before they arrive to the hotel. And what's the business need behind this need of knowing the nationality? Because they want to know, for example, if in July this year there are going to be a lot of Swedish people that comes into the hotel, so that they can put some people in the staff that speak Swedish, for example. Or they can also prepare activities, because they know Swedish people, again, like to go to the beach and to make some scuba diving, or if they come from Mexico, maybe they like dancing, so they can prepare the activities in the hotel. And also for kitchen arrangement. This is very important, because depending on the country you come from, you have a different taste, and you can prepare the meals for the people that, if you know in advance where they're coming from. So this is the business need. I will speak now very little about the machine learning basics, because this is how I'm going to explain the rest part of the presentation. We have in machine learning historical data. In this case, we will see how is our data set, which is reservation data set, booking data set. We will find patterns in this historical data, and we say we train the model, and then we make predictions to see if a new reservation is coming into the system, where is that people coming from. In this case, this is an example that comes from the United Kingdom. And then we have to retrain from time to time this model with new data, because we have to update the patterns in these models, and we retrain them and we make more predictions. Okay, so this is the very basics of machine learning. So let's see how this resembles to cooking a recipe. When you cook a recipe, you go to a market to buy ingredients, you clean the tomatoes or the fish, you transform these tomatoes into tomato sauce, you select the best parts of the fish to cook them, then you put that in the oven, and you taste the dish to see if it was good or not. So in machine learning, we don't go to the market, but we go to the different data sources. We get the raw data, it's called like that. We get the raw data from different sources. We will see in this use case where we get the data from. We clean the data. We will see what does that mean in terms of data, cleaning data. We transform and we select, which is something feature engineering in part is selecting the best part of the data. We cook this data into the model, in this case into the BigML model, to train the model and to find the patterns in the data. And then we taste the dish, which means evaluating the quality of the predictions. Okay, so let's go ahead and let's see where the data comes in this scenario. There are two main sources of data I'm talking about reservations that come from the hotel website itself, and reservations that come from Booking, Expedia, and other online travel agencies. These are the two main sources, and we get all the raw data. We are going to see now in the next slide what I'm talking about when I say raw data. It's not a very strange kind of document or very database. It's an Excel file, that's all. That's what we see here. This is an example, a basic example of our training data set, where we have each row represents a reservation, a booking, and each column is a characteristic of the reservation or the booking. Okay, so one row is one reservation, and for example, in columns we have the ID of the reservation, we have the day of the reservation, we have the kind of room of the reservations, and a last column, which is one of the most important, that is the objective column, the nationality of this reservation, because this is historical data. This is the data we are going to train with, and we know already, we now know which is the nationality, because the client has gone to the hotel, for example, last year, and he showed the passport, and we know where that tourist is coming from, because this is training data. In fact, this is the field we want to predict after training, when we are making the predictions. When a new reservation is coming into the system, and for example, for July this year, and we want to know where he or she is coming from. So what we had in this project was a 1-year historical reservation data, an Excel file, nothing strange, no SQL database, no Hadoop, no nothing, no big data. You can see here the characteristic of this historical data. It was 260,000 reservation with 80 fields, yeah, a lot of fields for each reservation, and a size of 150 megabytes. That's not a lot. That's not big data. I want to point this because we usually don't work with what we call or what somebody calls big data. It's not necessary to have a lot of data to make very interesting projects like this one. And we will see that after cleaning, we will have less than 150 megabytes of data. We are in the phase of getting data. This is our first data, the data the client sent us. Let's see how we clean the data. What does it mean that the data is not clean? Here you have again the data set, and I will point out now here some dirty data set. For example, this asterisk here. This should be the name of the tourist, but as it's a field with free text, well, somebody, instead of putting the name, put an asterisk. So we have to clean this data because an asterisk doesn't mean anything. So what we would usually do here is put this field as if we didn't have the data, so put it in null. There are also other cleanings that we have to perform before putting this into the BigML oven. For example, this is the origin of the reservation in terms of IP address. We saw that sometimes if it comes from the United States, this is in Spanish, as you can see this data set, in some instances we can see EEUU, which means USA, but in some other instances there is the EE.UU. And in some other instances we can see Estados Unidos. So we have to normalize this data and we have to clean it and put it just in one way because it's just one country. So it has to be named the same in all the instances. This is, again, cleaning the data. We also see here some problems with accents. As we have different data sources, some data sources have different language codes. So in this case, Doble Básica, which is in Spanish, Básica has an accent, and some systems don't understand the accent, and some others do understand the accent. So we have also to normalize this data. And in fact, what we did was removing the accents in the data set. And also with capitals and non-capitals. As you can see here, the Doble Vista, the second V, and the P is in capitals in the second instance, but non-capitals in the first instance. So we have to also, again, normalize or clean this data with this. This is what is called clean. This is a very basic cleaning, but the concept I want to show you is that we have to do these kind of things with the data that arrives. And also, this is a date. So you can see here it's like a very large number, but in fact, is the four first digits are the year, the second are the month, and the two last ones are the day. So we could clean this, putting one column for the year, one column for the month, and one column for the day, for example. It depends on how you are working on with the data set. So more cleaning. What we did, we deleted rows without checking. That means that they didn't get into the hotel, so we don't know in the historical data which nationality they came from, or canceled reservations, because that's not useful for training. We also deleted some columns, IDs versus names. Sometimes you have, for example, the hotel ID and the hotel name, so you just keep one, or columns with very few data. Another actions we did was, as I said, delete accents and transform from the Excel file to the CSV file. CSV file is a machine learning ready file that we can put into this BigML oven directly. So we started with a dirty data set with 260,000 reservations, and after cleaning, we had 150,000 reservations from 80 fields to 46 fields, from 150 megabytes to 75 megabytes. Okay, let's see what transforming means in this scenario. What we saw is that we had a lot of nationalities to predict, because in 1 year there were people coming from 210 different countries, and that's a very big problem for machine learning, because the more classifications, the more, how you say, well, in this case, the more nationalities you have to predict, the more difficult it is to do that. And there were some nationalities that there was only one reservation in a year, so it had no sense to predict if there was coming only one people. So what we did was reducing this the number of nationalities to 20. Let's say very simple. What we did was keeping the 19 most used nationalities, and then in the 20th was like other nationality. And this is, in fact, this is more feature engineering than transforming. But well, I don't really know the difference between feature engineering and transforming, because when you do feature engineering, you are also transforming the data. And we put some new fields, which one of them was the reservation anticipation, which is the arrival date minus the reservation date, to see if the reservation was done very in advance. It depends. We saw some patterns here, depending on the country. The hotel country also, this is some new field that we added that we didn't have in the first data set. And the hotels stars also, this is something that we added later. So we started with a dirty data set, 260,000 reservations, 80 fields. We cleaned the data set, 150,000 reservations, 46 fields. We transformed the data set we added 3 more fields. So we got into a 80 mega file. And then we started with the feature engineering. Feature engineering, very simple, is like extracting signal from noise. This is something that we have to do in every project. We have to know the business very well, and if we don't know it because we are expressing data but not in business, we have to speak with the business guys into the company, so that they can tell us which are the things or the features they think are most predictable or have more predictive power. But this is a very simple view of the feature engineering. In fact, it's a recursive task. You select some fields, you train the model, you make predictions, you evaluate the quality of the model, and you see if the feature you have introduced or you have deleted has more impact in the quality of the model. So this is a very simple way of seeing feature engineering. This is something that, as far as I know, it's very difficult to automate. And we still do it manually. There are some tools that can help you to see the correlations, etc. But it's mainly done manually. So the final data set we started again with a 260,000 reservation data set with 150 megas. We cleaned that into a 65 megabytes data set. Then we ran into 80 megabytes data set after transforming it. And after feature engineering, after selecting from those 49 fields which were the ones that had more predictive power, we had the final data set with 150,000 reservations or bookings, 10 fields, and 55 megabytes. No big data, and this is an important point. With a 55 megabytes, we were able to make a very nice model. So what is cooking in the oven? We got this data set, this final data set, and we use BigML, of course, machine learning to learn the patterns from. And what we see is this picture here, where I'm sure you will see later this is a decision tree where we can see the historical data and the historical patterns. Okay. So the algorithms that we use in in BigML are trees and different kind of ensembles, logistic regression, neural networks. What we did in this use case, this was done, I think, like 5 or 4 years ago, and we trained with all the kind of models we could. It was like brute force with many configurations, and we selected the final one. It was a random forest model. But nowadays, in BigML, we have the OptiML feature and the OptiML option, which selects the best model and the best configuration of the model in your dataset. So this is a very automated process, the final one, and we will see that is the one that is not taking much time in the project. The most part of the time in a machine learning project is the data part, as we will see just in a minute. So we taste the dish now. Let's see if it was good or not. And there are some quality indicators in a machine learning model, and of course you have that in BigML. You have accuracy or recall, precision. You can see the confusion matrix with very nice visualizations. And the one we focused on in this project was the accuracy, mainly because our client had already a model in place, but it was made with fixed rules, not with machine learning, and we wanted to perform better than them with this machine learning model. And what we performed was, on the left side, you can see the performance of their model in accuracy. It was 54%, and we got to 75% of accuracy. So that was 21 percentage points more than they had. So just to finish my presentation, I think I'm more or less in time. This is one last question I wanted to share with you. In these 5 phases of the project, data scientists want to learn a lot of models and machine learning and deep neural networks, etc. But most of the part of the project are spent in the first phases. A few years ago, I said it was like 70-30%. But now that we have these tools like BigML and AutoML or OptiML, this last part of the projects are getting, we are not spending that much time. And I would say that 90% or maybe more time we are spending on the data part, and 10% or even less in the training part and evaluation. This is in the evaluation is in the offline part of the evaluation. And what I mean offline is before putting the model in production. After putting the model in production, we spend much more time because we have to see the business KPIs, and we really spend a lot of time evaluating with A/B testing. So you have to have a bigger infrastructure to see how it's performing in production. But before putting that in production, before you have the best model you can to put in production, this would be the time spent in our machine learning projects.